Hello everyone. Okay, so today we're going to start off our lesson with our typical do now. And I want you to write the answers in your book. So pause this video to have a go at the do now and then we'll go over the answer. Okay, so I have drawn the particle arrangement orange juice. Orange juice is liquid, so the particles are randomly arranged. They're still close together, and that is what I've drawn. If it was gas, those particles would be far apart from each other, and they'd be spread out throughout the entire container. If it was a solid, the particles would be much closer together, and then they would be arranged in an orderly fashion. Okay, so the orange juice would take the shape of the glass that you put in. And that's because even though the particles are held close to each other, the particles can still move around. And the last question is, you need to explain why the orange juice can't be compressed. That's because the particles are held close together, so there is no space between the particles. Okay, so by now you should be able to highlight or tick off the bullet points that I've highlighted here. So I checked all of your Education Perfect answers, and some were pretty impressive and some were fun to read. So I'm just going to go over what we covered in the last lesson. So in solid, the particles are arranged in an ordered pattern, and the particles are close together. The liquid, the particles are arranged randomly, and they are close together, but not as close as the particles in a solid. In gas, the particles are randomly arranged, and the particles are far apart. Solids, they vibrate on the spot. Liquid, the particles can move around each other. In gases, they move quickly in all directions. And you can see the diagrams here. And essentially, it's this attraction between the particles that gives the different properties of solid, liquid, and gas, and we'll go over that now. Okay, so solid, the particles have very strong attraction to each other. So the particles are held strongly together, and that gives the fixed volume. Now, particles can't move from place to place because they are strongly attracted to each other, so they have a fixed shape. The particles are close together, and there is not enough space between the particles, so solids cannot be compressed. And an example here is a hammer. Now, liquid. Particles have fairly strong attraction to each other. Okay, not as strong as the particles in a solid, but it's still fairly strong. So particles are held strongly together, and that also gives it a fixed volume like solid. But particles can move from place to place in liquid. That's why liquids take the shape of the container instead of having a fixed shape. And particles are close together, so again, liquids cannot be compressed. Gases have, the particles have weak attraction to each other. So particles aren't held together strongly, so they take the entire volume of the container. And particles move from place to place, so there is no fixed shape. And particles are not close together, so there is a lot of space between the particles, so gases can be compressed. Okay, so today we're going to move on to the next learning intention, which is going to be about changes of state or changes of phase. Okay, so a change of state is when a substance turns from one phase to another. Okay, there are three phases or states of matter, liquid, solid, and gas. So a phase change may include solid converting to liquid, liquid becoming gas, and gas to liquid. And changes between each of these states is reversible. For example, water. The solid state of water is ice. Ice can become liquid, water. Water can then become a water vapor. And water vapor then can condense to water, and water then get frozen to ice cube. So the changes between these states is reversible. Okay, let's go through each change of state. So when a solid goes to liquid, that process is called melting. When liquid goes to solid, that's called freezing or solidification. When liquid goes to gas, that's called vaporization, okay, or boiling and evaporation. When gas goes to liquid, that's called condensation. Then when solid goes to gas, that's called sublimation, which is not often seen. And when gas goes to solid, that's a reverse sublimation, or you can call it deposition. And I want you to draw this in your book. So you can pause this video and do that. Okay, so here I'm just showing you, examples of boiling and evaporation. Okay, so if we were at school, we would be dealing with dry ice, and that would have been cool. So dry ice is solid carbon dioxide. We're more used to hearing carbon dioxide gas, but solid carbon dioxide does exist, and that is called dry ice. And when we put dry ice at room temperature, it undergoes sublimation, which is when solid directly turns to gas. Okay, it doesn't go from solid liquid to gas, it goes directly to gas. Now, when we're dealing with dry ice, we need to be very careful, because if you touch it, it can give you instant frostbite. So you need to use tongs. And if you inhale too much carbon dioxide, it can suffocate you. So hopefully when we're back next week, we can have a go at these. So you need to be very careful when you're dealing with dry ice. So, how can these states change from one to the other? Well, that's because we have heat energy being added or taken out. So this is a really cool video. I will post this on OLE, so have a go watching this. It's really cool. Okay, so the particle theory of matter. So there is a theory called particle theory of matter, and I'll go into more details later. And it says all matter contains energy, but the amount of energy differs between the different states. So gases have the highest energy, followed by the liquid and a solid. So if we add heat energy, the particles are going to gain energy. So if we heat up solid, it'll gain energy and become liquid. If we keep on adding heat energy, the liquid will become gases because the particles gain more energy. Likewise, when we cool things down, when we decrease the temperature or heat energy, the particles will lose energy. So if we cool down gases, it'll condense to liquids which have lower energy. And then if we keep on cooling it down, it will freeze. It'll solidify into solid, which has the lowest energy out of gases, solids, and liquids. Okay, so as I said, as the particles gain more heat energy, the particles move faster and they get further apart from each other, and that's because heat energy gets converted to kinetic energy. So as I said, particles and gases, which have the highest energy out of liquid and solid, are moving the fastest, particles in the liquid, less fast, and particles in the solid, much slower. When we add heat energy, it gets converted to kinetic energy, and the particles move more quickly, and this can result in changing states. For example, when we heat a solid, the particles move much faster and can break free from each other, and they become liquid. And if we continue to add more heat, the particles will move more quickly, and they become gas. When we remove heat energy, by cooling down, this will make the particles slow down, and this can change the state as well. For example, from gas to liquid, and then to solid. We also observed a state change when we were boiling our water. Remember in the investigation? When we heated the water, the temperature on the thermometer increased, and during this time, the particles were gaining heat energy, the water particles, and then they got converted to kinetic energy, right? So the water particles moved faster, and when it reached 100 degrees Celsius, they evaporated, or they changed state from liquid to gas in the form of water vapor. This is another video that I want you to watch, and I will post this on OLE. Okay, so hopefully we can now tick off or highlight these bullet points, and I also have Education Perfect for you to do, so please get on to that, and that is due today. Okay, thank you guys, have a great day.